All right, I got a question from back into chapter 8, and I'm sure it's because you guys are reviewing and getting ready for the exam. And let's just read this. This is the momentum chapter. There's a little collision going on. So, chapter 8, number 24, it says, suppose that a clay model of a Kodiak bear has a mass. So, I won't try to draw a bear here, but I'll say it has a mass of 0.2 kilograms. And it slides on the ice at a speed of 0.75 meters per second. It runs into another clay model. Right, so here's another little clay model bear. Runs into another clay model, which is initially motionless and has a mass of 0.35 kilograms. So a little more massive, but the important thing also is initially it's zero. Being made out of soft clay, they naturally stick together. What is their final velocity? All right, so maybe I'll put like a little dotted line and say, okay, now they're going to bump into each other, and so they stick together. And at this point, you might want to think of it as just one object. If you add the two together, it's 0.55 kilograms, moving at some unknown speed. Okay. And one of the things I keep hearing is people are going, well, how do I know if this is elastic or inelastic? Well, let me get to the definition of elastic. First of all, it's elastic if they say it's elastic. A collision is a collision whether it's elastic or inelastic. And I want to emphasize that. Momentum before equals momentum after all the time when we involve both objects, period, elastic or inelastic. The word elastic and inelastic has nothing to do with conservation of momentum. It has to do with kinetic energy. Is the kinetic energy before the collision the same as after? If the answer is yes, it's elastic. If the answer is no, it's inelastic. So in this problem, they have said nothing about the kinetic energy. So by itself, I still would wonder if it's elastic or inelastic. And so without them telling me, I better assume that perhaps it is not elastic. Elastic is like a special case. So I definitely don't want to say that the kinetic energy before is equal to the kinetic energy after. That would be saying it's elastic, and I don't know that, so I'm going to say it is not. In fact, I'm going to give you a little helpful hint. If they ever stick together, that means they bumped and they hit and they rubbed, and that rubbing made some friction, which makes some heat energy, which must have come from kinetic energy. Therefore, the kinetic energy must be a little bit less. So anything that sticks together is definitely not elastic. So indirectly, they did say this is an inelastic collision. Okay. So again, I would not do something like this. I would not say initial kinetic energy is final kinetic energy. No. Again, I would only do that if they said it was elastic. And of course, that would also mean they don't stick together. But this one does. So this is definitely out. But this is always in. Okay. So I'll go ahead and do the momentum before. And so before would be a mass of 0.2 and a speed of 0.75. And the other object would have a speed of 0, therefore a total momentum of 0. So that's before the collision. And then after the collision, thinking of it as one object, it's 0.55 times the final velocity. So now it's just a matter of putting in our numbers, and we got the answer. So 0.2 times 0.75 divided by 0.55, give me a speed afterwards of 0.2. And maybe I should look here at significant figures. I didn't put it up here, but there was a 0 there, a double 0 there, a 0 there. So we've got 3 significant figures. So I'm going to go with 2.273 meters per second for the final speed. Okay? Conservation of momentum. That's simple. The word elastic and inelastic have nothing to do with the principle of conservation of momentum. It has to do with kinetic energy. All right, take care.